Hello and welcome to section 2.8 lesson. So before f prime of a was what we primarily talked about, and this was an actual number spit out by this difference quotient that gave the slope of the tangent at that point. So now we're just defining a general function, replacing a with x, meaning that this is a function in its own right, and I can plug any value of x in there, and it's going to spit out the slope of the tangent line to the function at that value of x. So for example, let's look at the function f of x equals x cubed. So if I take my limit of the difference quotient with x now instead of a, what this is giving me is another function in terms of x. And this function is actually outputting the slope of the tangent line at that x value. So here's x cubed. So for any value of x, we see that how the tangent line changes, right? So this derivative function, 3x squared, is graphed here, this parabola. And notice as I move along f of x equals x cubed, notice what the slope of the tangent line is, and notice what the output value is of that derivative function. So the derivative is a new function derived from the original function that's giving me slopes of tangents as output. So let's explore graphically what these derivative functions tell us about the graph of the original function, because that's really the whole point of the derivative. I'm going to trace the derivative function. Here's my given function, this red function. Let's do this. There. So as I move this point, is it going to let me move? Yes. As I move this point along the function, notice how the tangent line is changing. And this blue is the graph of the derivative function being traced along with the original function. So notice that the output from the derivative, like for this point x equals 4, is minus 5.6. That's the slope of this tangent line. So as I move along the function, I see that this derivative is being traced out. And when I get to this minimum value on the function, notice that the tangent line's horizontal. So of course that has a 0 slope. So that's where this derivative is 0. So I'm going to keep moving. Now my function, the red curve, is increasing. So that means that the slope of the tangent's positive. So the derivative has a positive, here's the derivative. The derivative has a positive y value. And I keep moving. And you can see how as I trace along the original curve, the derivative function is being traced out. And where the original curve is decreasing, that means that its rate of change is negative. It has a negative slope. So the derivative's negative. It's beneath the x-axis. But where my original curve is increasing, that means the tangents have positive slopes. So my derivative is positive and above the x-axis. And then, of course, where my original curve has a horizontal tangent, the slope is 0, and that's where the derivative curve crosses the x-axis. It has a 0 y value. So I'm going to continue along. And this blue curve is the graph of the derivative of the given function. So this is just kind of summarizing how the derivative function is either below or above the x-axis depending on where the original curve is increasing or decreasing.